Here we're introduced to another connective, exclusive OR. The exclusive OR connective, written XOR or just as a plus sign with a circle around it, I believe it's O plus in LaTeX, is just what it sounds like. P XOR Q is true when exactly one of P or Q is true, but not both. So write down the truth table for P XOR Q and for P and not Q, or not P and Q, and hence show that P XOR Q is logically equivalent to the earlier statement. So we'll just start by writing a truth table as the problem directed. So we have P and we have Q. True, 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 false, false, true, false, false. Then we need to do P XOR Q. We know from the problem statement that this is true when exactly one of them is true. So in these two cases, but false if they're both true and false if they're both false. Now I'm going to make quickly some columns for not P and not Q. I find it's really helpful to go step by step, especially when there's a negation involved, because otherwise you can sometimes find yourself running in circles. And writing an extra column takes such a small amount of time, and it can really save you a lot of points on homeworks and midterms, especially when maybe you're stressed and not thinking quite right. So when in doubt, write an extra column. It doesn't actually take that long. So here, false, false, true, true, and false, true, false, true. So now we'll just start with the first part of that expression, which is P and not Q. We know this is true when P is true, not Q is true. So that's the second line here. And in all other cases, this will be false. Now, we do the same for not P and Q. So not P is true in the bottom two rows, and Q is true. Excuse me, not P is true in the bottom two rows, and Q is true in the top of these rows. So in the third row, this will be true, and the others will be false. So when we take the OR of these last two columns to do this statement, what we end up with is false, true, true, false. And we notice that this column and this column are exactly the same, which means that P XOR Q is logically equivalent to P and not Q, or not P and Q.